Now we will turn our attention to another topic called morphological reconstruction. So far we have seen four different operations in morphological image processing, such as erosion, dilation, opening and closing, and all these operations involved two major components. The first one was a image and the second one was a structuring element. The reason for using morphological reconstruction is there will be certain part in the image which is some structural peculiarities, and we have to extract only those structures out of the entire image. And we will see one example after we discuss some basic operations in morphological reconstruction. There are two different basic operations in morphological reconstruction. The first one is called geodesic dilation, and second one is called geodesic erosion. Okay, so we will first see what is geodesic dilation. So unlike the normal morphological operations where we had one image and one structuring element, we will have three different components for morphological reconstruction operations, such as geodesic dilation and geodesic erosion. The first one is called a marker, and we will denote that with a symbol F, and that includes all starting points for the operation. And second one is called a mask. We denote it as symbol G, and that is actually constraining the transformation. And the third one is the structuring element, and which determines what kind of shape we need to extract out of the image. Now I will designate this structuring element with the symbol B as usual. Now if you want to define the first operation, that is the geodesic dilation, then it is defined as follows. The geodesic dilation of a, so I will write it along with the equation. The geodesic dilation of an image or a marker F using a mask G of size 1, or if you apply the operation for the first time, and this is defined as you take the image or the marker, then you dilate it with using the structuring element, then you take the intersection of all those elements with the elements of the mask. So this is the definition for geodesic dilation. So we are familiar with this operation, that is you will have an image F and you will have a structuring element B. The first thing that you need to do is you first find the dilation operation and you intersect all the set elements of this result with a set G. Okay, so I will show an example where the idea will be a bit more clearer. Okay, now if you want to apply this geodesic dilation operation of an image or a marker F with a mask G for n times, then what you have to do is, so you find the geodesic operation of the image F with the mask G for n minus 1 time, or of size n minus 1, and upon that result you apply the geodesic dilation operation one time. Okay, so this is the recursive relation by which you can find any size of geodesic dilation operation. But if someone asks what is geodesic dilation operation if you apply it for 0 time or of size 0, then the answer is F. Okay, so you can use this relation and this relation to find the dilation operation or the geodesic dilation operation of any size. Okay, so suppose that if you want to find the geodesic operation for 3 times, then I will be writing dg of f3 is equal to dg of 1 applied on dg of f2. Okay, now if you expand this further, this will be geodesic operation 1 time on geodesic operation 1 time upon geodesic 1 time on the image f. Okay, but the question is, what is dg of 1? Then this will be the geodesic dilation 1 time and geodesic operation 1 time, geodesic dilation operation 1 time upon geodesic operation 0 time on the image f. Okay, so this turned out to be dg1 of dg1 of dg1 of, and what is geodesic operation applied 0 times? That is f. So that is f. Okay, so this is how you can use this relation recursively to find the geodesic dilation of any size. Okay, now we will see an example. Now we will see a graphical illustration of this example. Now let's look at a graphical illustration of this operation. Okay, so here I have a starting point or the marker f, that is, this is the marker f, and this is my structuring element b. So b is written over here, and this is the mask upon which we have to perform the AND operation. So I will write the equation, that is, the geodesic dilation of the marker f applied 1 time is equal to, you have to take the image f or the marker image, first dilate it with using the structuring element b, then you find the intersection with the mask g. So this is the image f. So you have to find the dilation operation of this image. So the dilation operation will produce the first result when the structuring element is over here, because you are performing the dilation operation. So if the center of the structuring element is here, there is an overlap between this structuring element and this pixel in the original image. So this pixel will be included in my result. Okay, then you move the structuring element back to this position, that is to the next position. So this is the center. So you can see that, so there is one more element which is overlapping with the pixel in the original image. So this pixel will be also included in my output, and this continues on and on. So you will see that these are the pixels which will be set, or this which will be included in my output. So that is, and this will be also included in my output. So you can see that these pixels are selected as the output, or these pixels are included in the output. So this is the result of dilating the marker with the structuring element b. And as the next step, you have to intersect this image with image, that is g. Now when you perform the intersection operation, one way of looking at the intersection operation is, you can take the logical AND operation with the two images. So if you have a pixel which is 1 and 1, then result will be 1, and if you have 1 and 0 or 0 and 1, the result will be equal to 0. Okay, so if there is 1, you will be selecting that pixel into my output. If that is result is 0, then I will not select it. So when you take this pixel and this pixel, there is 0 here and there is 1 here, so it will be 0 at this point. Okay, because you are performing 0 and 1. Now here you have a 1 and here you have a 0, so the result is 0 again, and here you have 0 and here you have 1, so the result is 0. And the first one will be produced when you intersect this one with this one, so that you will get a 1 here. And if you continue this operation, then these three pixels will be selected as the result of geodesic dilation when you apply it for one time. Okay, and if you apply it for multiple time, I will say that aspect also. when you apply it for multiple times, so this is the result now, and if you apply a geodesic dilation over this image, then what will happen is this image will be expanded, so result will be expanded, and when you find the intersection of that result with this mask, then you will see that certain portions of this mask will be selected and all other will be deleted, or other will be removed. Finally, our geodesic dilation, if you apply it for multiple times, there will be a point at which the geodesic dilation operation does not grow any further. So there are certain applications for this particular operation, and we will see it. Now let's turn our attention to the second basic operation of morphological reconstruction, that is geodesic erosion. The geodesic erosion of the marker F using the mask G of size 1 is defined as: you first take the image F, then you erode it using the structuring element B, then you perform a union operation with the mask G. So this is just the complement of geodesic dilation, where instead of erosion we use dilation, and instead of union we used intersection. This is how the geodesic erosion operation is defined, and if you want to perform this operation n times, then the geodesic erosion of image F using the mask G performed n times of size n is defined as: you first find the geodesic erosion operation of F n minus 1 times, then upon that result you perform the geodesic erosion operation 1 time. And to complete the recursive relation, if you perform the geodesic erosion 0 time on an image F, the image will be itself. Now let's look at the graphical example of this operation. So here I have a figure. This is my original starting point image F. This is the structuring element, and this is the mask. So what you have to do is you take this image and first perform the usual erosion operation. So when you perform the usual erosion operation, you have to completely confine this structural element inside the object. Then only you will get a pixel that is with value 1, otherwise the pixel value will be 0 in the result, or in the eroded result. If you take this center and if you place it here, you will get a 0, and if you place it here you will get a 0, if you place it here you will get a 0, because this will be the position of the structuring element. So you have several elements which are not overlapped, so the result will be 0, and you will get the first ever overlap when you place it at this point. Is the structuring element will be at this position, so the structuring element is completely confined with a pixel intensities of 1, so this pixel will be there in the result. So this is the result, and if you place it here also at the second point, that is if you place the center over here, then you will get the position of the structuring element like this. So the structuring element is completely confined under an intensity of 1, so this will be also taken into the output. So this is how you are finding the eroded result. So this will be the output that you can get. Okay, now as the next step of the geodesic erosion, you have to take the union of this image as well as this image. So you can consider the union operation as the logical OR operation. So where if you have 1 or 0, the result will be 1, 0 or 1, the result will be 1, and 0 or 0, the result will be 0, and 1 or 1, the result will be 1. Using this logic, you can take the eroded result with the mask and you perform the OR operation. In the final result, you can see that only this pixel and this pixel has 1 in common for both the images, so you will get a 1 at this point. Then you have 2 1s over here, so that 2 1s are in the result here. Then you have this entire structure contributed into the result like this. Then this single pixel is also there. So it is actually a combination or the OR operated result of this image and this image. So you will get the geodesic erosion, and you can perform this operation again. But one thing to notice is you can do this any number of times until you can see that the final result will be looking like the structure of my mask image. Okay, that is due to the fact that the first operation, that is the erosion operation, will be reducing this size, but the mask will increase its size, or it will add extra elements to the result by performing the union operation. Okay, so the erosion will decrease the size, but the mask will increase the size until a point wherein you have only the mask. So the final result of the geodesic erosion will be looking like the shape of my mask.